Alright, in this video I'm going to try to talk about the Doppler effect, and I'll be referring to what we call the general form of the Doppler equation, because I want to be able to do this so that we only need one equation. You'll see several books that talk about one equation for when the observer's moving and the source is stationary, and when the source is moving the observer is stationary, and when they're both moving and which direction they're moving. And rather than teach 5 or 6 or 7 different equations, we're going to use the general equation, and hopefully we will be able to use that general equation in every situation. So that general equation is that the frequency heard by the observer is equal to the frequency of the source, which is going to be multiplied by 1 plus or minus the velocity of the observer divided by the velocity of the sound, divided by 1 minus or plus the velocity of the sound divided by, the velocity of the source divided by the velocity of the sound. Okay, so keep in mind that the O means of the observer, the S means of the source, and then the V, which doesn't have any subscript, is the velocity of the sound itself, which is not going to change as we go through the Doppler effect. Okay, so we're going to look at this particular example, and we're going to look at 4 different situations. The first of which is a train is traveling towards Mr. Bywater, that's me, at a speed of 44 meters per second. I'm very excited about the Doppler effect, so I stand in the middle of the track listening to the train blow its whistle. The whistle of the train has a frequency of 415 Hertz. So the first question is, what frequency will Mr. Bywater hear as the train is approaching? Okay, so let's go ahead and work that out. Now, as we're doing this, I'm going to draw a picture every single time, because it's important that in order to be able to do this without having to worry about several different equations, that we have a certain convention. Okay, so here's my train, which is traveling in this direction. Here's me standing in the middle of the train track. Now, using this equation, you see there's a plus and minus on the top and a minus and a plus on the bottom. So when we're dealing with the velocity of the observer and the velocity of the source, what is going to determine whether this is a plus or minus is what direction it's traveling. Okay? For our convention, from the observer towards the source is always going to be the positive direction, regardless of which direction anybody is moving or anything. The observer to the source is always the positive direction. So let's go ahead and put the numbers into our equation here, and let's solve for the frequency that Mr. Bywater is going to hear. We already know that since the train is coming towards me, it should be something higher than 415 Hertz. Okay, so let's go, the frequency of the observer is equal to the frequency of the source, which was 415. Okay, and then on the top we're going to have 1. Now this one is dealing with the observer, and the observer in this case isn't moving, so it doesn't really matter if it's a plus or a minus, because it's going to be 1 plus or minus 0 divided by the speed of sound, which we're going to assume is 343 meters per second. Okay, so 1 plus or minus 0 divided by 343 is just going to leave us with 1. Okay, now on the bottom we're going to have 1, and then it's going to be plus or minus. The train is moving in this direction, which is opposite what we have defined as being the positive direction. So that means we're going to have a minus, and then the velocity of the source, which is 44, over 343, which is the speed of sound in air. Okay, so from there we should be able to solve the equation. Let's pull out our calculator. And so we're going to type in 415 times 1 over, now the stuff on the bottom I'm going to put in parentheses because I've got a subtraction there. So 1 over 1 minus 44 over 343. And so close both sets of parentheses, and I get 476 Hertz. So the frequency heard by the observer is 476 Hertz. Alright, so let's go on to the second one. What frequency will Mr. Bywater hear after the train passes and continues on down the track? So we're assuming I'm still standing on the track. I know the question that you're all asking is, Well, how is he still alive and hearing the sound if he's still standing on the track? Well, that's for me to know and you to find out. If you ever do find out, I'll have to kill you. Anyway, let's go on with the problem. Okay, so now we've got the man, right? There's me. The train is now passed and is continuing on. Okay, so there we go. And so there goes the train. It's going on past. Now our convention is still that the observer towards the source is positive. Okay, so this is going to change things a little bit, right? So the frequency that the observer hears is equal to the frequency of the sound, which is 415 hertz, okay, times 1 plus or minus the velocity of the observer, which is still 0, right? So it's going to be plus or minus 0 over 1. Now it's going to be minus or plus. Now the train in this case is moving to the right, which according to our convention, remember, observer towards the source is going to be our positive. So that means that the train is now going plus, and then 44 meters per second over 343. So we punch this into our calculator. Of course, again, now this time, since the train's going away, we expect it to be a lower frequency. So hopefully that's what we get. 1 divided by, and again I'm going to put this in parentheses, 1 plus 44 over 343. Close it up. And we get, ooh, just kidding. Oh, I put an extra parentheses there. Sorry about that. 367.8, so 368. So 368 hertz, which is less than the frequency we started with, which makes sense because the train's moving away. All right, let's look at a different one. Let's go on. We're going to keep the same numbers, but in this situation, let's go back to the beginning where the train's coming towards me. All right. Ooh, different train this time. Got a different. Let's even put the little cattle guard on the front. Okay, there we go. And then you got the little whatever that is that connects the wheels and makes it go. All right, so the train's still moving towards me, but this time I'm going to decide to start running away. So here I am. I'm going to run away. Okay? Now, even though I'm moving, we still consider the observer towards the source as being positive. All right? So we can still use that same equation. Frequency of the observer equals frequency of the source times 1 plus or minus the velocity of the observer over the velocity of the sound divided by 1 minus or plus the velocity of the source divided by the velocity of the sound. So let's go ahead and put those numbers in. So the frequency of the observer is going to be equal to the frequency of the sound, which is still going to be the same thing, 415 hertz, okay, times 1 plus or minus. Now the velocity of the observer is 10, right? So 10 over 343. Now, I am moving in this direction to the right. We already said to the left in this case is positive, right, towards the source, which means I want the minus here. So let's get rid of the plus. So it's going to be 1 minus 10 over 343. And the train is also moving, so that's going to be 1. The train is also moving opposite of our positive convention, which means it's going to be 1 minus the velocity of the source, which we said earlier was 44 meters per second. So 44 over 343. So there, we're going to work that out. We'll go ahead and plug those numbers into our calculator. Okay, so I can actually go in and type in the same thing. So we're going to go 415 times, I'm going to put in an extra parentheses here, 1 minus 10 over 343. Okay, so we got 1 minus 10 over 343 divided by 1 minus 44 over 343. And we get 462 hertz. Okay, so the frequency heard by the observer is 462 hertz. All right, which makes sense because when it was just the train moving towards me, it was 476. since I'm running away, I should get something slightly less than this. Okay? And so there you go. And I'm not going to do the last one because then my video won't fit on YouTube, and I want it to fit in my 10-minute segment. So I've done 3 equations. Hopefully you get the right idea. Just remember, every single time draw the picture and draw the convention that the observer towards the source is positive, and then you should be able to work it out from there. So hopefully you can finish the rest of the questions on the worksheet. Good luck, and have a great night.